This conference will now be recorded.
Hi, welcome back. Good morning, all. Mm, Yeah, yesterday we were discussing sets, and then we saw replica set, we saw deployment set, and then we saw daemon set, and later finally we discussed stateful set. Replica set, you already know, it will just maintain the number of replicas you want for your pod, but it cannot update the image versions. So application teams find it difficulty to change the version of their application, and for that purpose we got deployment set. What it will do is, it is like it does same like replica set, but you can update the image versions, you can go for new versions of your applications. But deployment, internally it will create a new replica set and it will perform the rolling update. It will make one pod running in the new version and it will remove one pod in the old version. That is like rolling update strategy. We saw this already, and then we discussed daemon set. Daemon set makes sure every pod runs on one pod runs on each and every node. For cluster administrators like to collect the logs and node metrics, they use daemon set. If any new node comes up, daemon make sure the pod runs on that as well. If any node goes down, then daemon set will make sure to delete the pod on it as well. So that is the daemon set. And we saw this one example with fluentd to collect the logs actually. And later we discussed stateful set. Stateful set is somewhat tricky. Uh, Practically, we don't use much in projects, stateful set, but we should understand for the interview purpose. I saw a lot of Kubernetes documentation and I saw a lot of articles as well, but no one explained it properly in their sites. What is stateful set? What is the difference? But yesterday I did some research and then I prepared something like this. Before you understand stateful set was not there in previous Kubernetes versions. Why they made it available is to bring the databases into containers. Containers were originally created for microservices and then these are for purely stateless applications. But over the time, Kubernetes made it available for the database kind of applications through stateful set. Before understanding stateful set, first we need to understand how the database kind of softwares will work. There will be a primary DB. It can do the both read and write operations. It has its own storage, and there will be multiple read replicas based on your traffic. Based on your traffic, you can have multiple primary DBs and then multiple read replicas also. But this can manage decent, like millions of customers also. This can manage. And if you have primary DB, it has its own storage and read replicas also. This is also DB. It has its own storage. if if someone performs write operation in the website like registering the user, then this will come to the primary DB. It will create the user in the user table and then it will sync the data to the read replicas. So while thinking in the cluster, first this one should understand what are the read replicas available. First it should get all the read replicas information and then contact each read replica about the data sync. It will inform the read replicas, I did this data change. You also perform the same from your side. Okay. So that's what it does. First, it should know what are the replicas available inside the cluster, and it should contact each and every read replica to sync the data. That is the two operations. Find out the replicas and communicate the changes. If you apply normal deployment, how can you find out other pods? For example, if you hit if you hit if you hit nginx service, like if you hit the service attached to the pods, then you get the cluster IP. But the use of headless service is, if you hit headless service, then you will get the individual IP address attached to it. So this problem one is solved. Definitely you will face a question why you need headless service for stateful set. If you use normal service, you will get the cluster IP. You don't know what are the ports connected inside the cluster. But if you use headless service, you will get all the addresses inside the cluster. Okay. So in that case, what MySQL does is first it will do NS lookup on the headless service. Then it will get all the IP addresses. That is the first operation. So that is why we use headless service and then communicate the changes. So it got all the IP addresses. Now it will connect to the RAID replicas using their IP address and it can effectively communicate the changes. Okay, and cluster every pod in the stateful set will have its own storage. Okay, through the PVCs, or you can create an PV and attach to it. That is stateful set. So the difference between stateful set and deployment is for stateless applications, stateful set is for stateful applications. Deployment will use common PVC, but stateful set will use uh, different storage for different pods and use ideally stateful set is for like MySQL, ELK kind of applications. Deployment use normal service, but stateful set use headless service. And inside stateful set, you will get unique identifiers like the name of the pod you get is web-0, web-1, but for deployment you will get some random pod name, and the order of deployment in stateful set is first web-0 will be come to running and then web-1, web-2 like that. It's an ordered approach, but in deployment it will be like randomly it will start all the pods at a time. Okay, if you understand this well, then you can definitely answer this. Interviewers ask this as a tricky question. Okay, any doubts still here? And we will configure this MySQL 0 as a return database, and we will configure MySQL-1 dot headless service. If someone performs login operation, then the request will come directly to one of the read replica. Since it's a just read thing, nothing will happen. That is how the database clusters usually work. And then Kubernetes creators carefully does that using stateful set. Okay, so we can see this demo once again. kubectl get nodes. Okay, we have our cluster running and stateful set. We can see the syntax, but definitely you should attach headless service to the stateful set. It is nothing but mentioning cluster IP none. That's it. And then syntax is same as like replica or deployment set. Match labels. You are just attaching the service. Let me name it as stateless. Okay, nginx stateless, and then stateful set matching with labels nginx volume mount. We are doing EBS. Okay, so let us take MySQL itself. Var lib MySQL 3306, name MySQL 4. This is MySQL configuration actually. Tables app. Let me give MySQL. 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 Okay, how do I know this 3306 and where lib MySQL is? You need to refer the image. Okay, you need to mount the volumes to the where lib MySQL. And by default, MySQL opens this port, mounting it where lib MySQL, containers, MySQL image, and then I just changed from Nginx to MySQL. That's it. Service name MySQL, stateless, MySQL port. Okay, so everything is ready. And there is one more thing missing. Some environment variable we need to give to provide the password. MySQL root password. Usually we will give it through the secrets. Then that also we can discuss while discussing RoboShop. Value admin 123. Okay. Now push this kubectl apply -f 04 stateful set. Okay, export kubeconfig equal to kubectl get pods. Watch kubectl get pods. Okay, once 0 is ready, then only it will go for 1 and then 2. Okay, 0 is running. Now coming to 1. So that is done. Kubectl get svc. Okay, stateless service is also done. Now if you go and check here volumes, So we got the volumes created kubectl get pv. Okay, this one EBS MySQL 1, EBS MySQL 0. These are like old volumes. This is the one, DB960. Is it not coming into search? Okay, so these are our MySQL all just now. Okay, so now let us go and then see how it does. kubectl get pods, kubectl exec pod hyphen exec pod mysql exec it mysql hyphen 0 hyphen bash. Now applications will configure this mysql 0 in their right endpoints. Okay, so imagine a request comes to this MySQL 0 write request, then it will do that write request here, and it needs to send the data to the read replicas. So first it performs ns lookup nginx or MySQL stateless. Okay, ns lookup command not found. Then we need to update. Let us see what is the release. dbn. Okay, apt-get update is good. Oh, apt-get install find utils -y. Apt install dns utils. Okay, unable to locate package. So apt update is getting failed. That is the problem. Now we need to check this why it is failed. Hmm, they are saying restart. So in this it is working fine. So let us restart that kubectl delete forward mysql -0. Okay, now running kubectl exec -it mysql -0 bash apt update. Wow, has some problem really. Okay, so let us do mysql1. Just think this is the master. Apt update and apt install dns utils ns lookup. What is it? mysql hyphen stateless. Okay, now you see it got all the addresses attached to it. These are the 3 ports, and except its own IP address, then it will reach other 2 ports. How it will reach is like just through the IP address also it can reach, or it can reach to IP address, or it can reach with name dot headless service. For example, telnet is there. Okay, telnet install debian. Apt install telnet. Okay, if it is this IP address, then telnet, this IP address, port number 3306. Okay, so this is connecting. Okay, so that's how it replicates the data. Okay, you need to understand this whole thing and you can tell the answer confidently. Any doubts still here? Okay, practically we don't keep databases in containers. This is just for concept purpose. Maybe maximum we will keep something like RabbitMQ, Redis, some kind of cache applications. Okay, so if no doubts, we can proceed to the next topic. Can check liveness probe Kubernetes. So we did some health check configuration actually while discussing Kubernetes. Kubernetes Docker, while discussing Docker 5, we did some health check. Okay, but nobody will do the health check at the image level. Everybody we do the health check at the pod level. Okay, so this is the liveness probe, readiness probe, and startup probe. So earlier these two were there. Startup probe is a recent one. Okay, your pod is running. If it get into some problem, how Kubernetes knows that pod has some problem really? That is through the liveness probe actually. If you configure liveness probe, Kubernetes will be continuously checking that, and if something goes wrong, it will detect and then it will restart the container. That is the liveness probe. Readiness probe is your container is just ready, but it will not able to accept the request. Something else going on while starting the container. So readiness is whenever your container is completely ready to accept the connections from the front end or some other pod, then it is like readiness. Okay, and the startup is like this is the new thing. This is like when you start up a Spring application. Generally, Spring application startup will take maybe 1 or 2 minutes. Okay, that is for the startup. Your Spring application or Spring microservice or Java microservice is completely started and running. Okay, so first thing this will be done. Your application or your Spring server or Spring microservice should start completely before it does these two checks. Okay, you can see these two will be disabled until this is success. First this should get success, after that these two will start its probe. Okay, so mostly this is like a slow starting container. Slow starting containers means we are seeing the now Nginx container within seconds it comes up and running. But if it is a heavy real-time application doing some heavy job, then it will take 1 to 5 minutes to start up and running. Okay, so for that purpose, startup probe is really useful. Otherwise, you cannot see the difference actually. Okay, so this is the liveness probe syntax. For example, I'm configuring the liveness probe. Now let us do this and then, yeah, first let us do this and understand what are these parameters. Okay, pod definition, just a name, image is something like busy box, it's okay. And how it is starting the container is It is creating one file temp slash healthy and sleeping for 30 seconds. And after that, it is removing it and it is sleeping for like 10 minutes. Okay, this is for just demonstration only. So now liveness probe will happen whenever your container starts running. It will be continuously checking for this file cat temp slash healthy. Okay, initially it will wait for 5 seconds and then every 5 seconds it will check for this file exist or not. If it is exist, it feels the pod is running good. If it is not exist, then Kubernetes will think that something wrong with this pod. I need to restart. This is like called self-healing. When something goes wrong, instead of you go and check something is going wrong and you find there is something wrong and then you will do the restart for the containers. Instead of that, Kubernetes can every 5 seconds it will check the health of your container. If it is success, then fine. Otherwise, it will restart. Now, if you see, it created healthy file and then it slept for 30 seconds. This 30 seconds, your pod is healthy. After that, it is removing it. Then it should get that alert, like Kubernetes will get that alert, something goes wrong, and then it will do the restart. Now we can see that. Okay, let me delete that stateful set. Okay, by default, these volumes may not be deleted since it is database things. So you just go and delete whatever is in available state. Okay, so these are not the things. kubectl apply -f 05 Linux Pro. kubectl get pods. Container getting created. Okay, now it is into running state. After 30 seconds, this file is getting deleted. Now it should show it is not in a running state. Now to check that, what you have to do is you need to check the events. kubectl describe pod liveness exec. So it created and now you check it. Liveness probe failed. Can't open temp healthy, no such file or directory. Now it should restart this container after some time. Now it is saying container liveness failed, liveness probe will be restarted. Okay, after some time, just like it will wait for some time and then it will do the restart. Okay, now you can see restarted 5 seconds ago. This is like called self-healing. You can again configure it with the HTTP requests. Okay, so for example, this one we are just seeing one one command, but you can configure it with HTTP or you can configure with port also. For example, if you are running Nginx, it means it is opening port number 80 by default. So you can check that port number 80. And at some point of time, if the port is closed, then Kubernetes will think that something wrong with it and then I need to restart. For example, let us do this with HTTP. This is the default thing. First it will delay for 3 seconds. After that, every 3 seconds it will do it, and it will check localhost/health on port number 80. So this will be like localhost 8080/health. Okay. If something goes wrong, then it will do the restart. Okay. So I think they configured something to fail it after some time. Okay. So now let us check this. Just to know the syntax, how can we do the HTTP? Because most of our applications will be HTTP and they will have some URL like this health check. Okay, so it restarted. They configured this image to fail after some time. So that's it for the demo purpose. And readiness probe. Okay, so this is also same, but readiness is like when you feel ready when your pod is running. Liveness is like health, and I feel like pod whenever you are running Nginx, whenever you feel there is a port number 80 open, then you can think like your readiness probe is, I mean your readiness is done from your pod side. Pod is ready to accept the connections. That is the readiness probe. So mostly liveness and readiness will be the same. Okay. So usually in our projects also we configure liveness and readiness both are same. Because when this port is open and it is able to serve the request in this, then it means it is ready as well. Okay, that is the syntax. Documentation also says same. These two are important when we are running real applications. Okay, readiness is this one. You cannot even see the difference actually. This is how we configure health checks using liveness and readiness. They will face a question, what is difference between liveness and readiness. Liveness is for the containers, for the Kubernetes to keep checking your health and do the restart if something goes wrong. Readiness is like initially the Kubernetes should feel the pod is ready for to accept the traffic. Okay, so that is the only difference. And so till now we have discussed all the necessary topics to create our Kubernetes pods, config map, secret, and storage, and quota, services, sets, all these concepts we need to learn to configure our RoboShop application in Kubernetes. Now, how it happens is now there will be a MySQL. This should be stateful set. Password is from the secret, not from environment variable. Okay. Similarly, we need what, some other MongoDB. All these applications should be stateful set. MongoDB, and then what is this? Redis and RabbitMQ. And we have our user service. It should be a deployment, and then service should be attached, normal service, and here headless service. Okay, and after user we have what else we have? That is another thing is catalog, and then cart, and then shipping, and then payment. Okay, so we may use config maps to provide some configuration to this. Okay, and then the user speaks to MongoDB. The user speaks to MongoDB. Catalog speaks to MySQL. And all this payment speaks to RabbitMQ, and then shipping speaks to MySQL, I think, and then cart. So all these deployments will speak to stateful set, like for the data storage kind of applications. In front of this, we have front end application. This is also deployment, and then service. This should be a load balancer. Okay, exposing to the internet. And then we will open this one. Public will open this one. So inside this, we configure our Nginx rules like reverse proxy. Okay, so now the request come here to this load balancer. Only this is open to the public. From here, the request goes based on the API/user. It goes here, and then /API/catalog. It goes here, and then it goes here like this. So now we will use all these Kubernetes resources to deploy our project into Kubernetes. So how we do it? It's not going to be a default namespace. It's going to be we will create one namespace called RoboShop. Okay, this name is for RoboShop project. If there is another project, they will create their namespace and they will deploy all these services. Okay, so this is going to be our application architecture, and we can start it from day after tomorrow, configuring one by one. Okay, everything is going to be deployment and service. Deployment internally has replica set and pod. And config maps and secrets required. Whenever you need some passwords, you will configure it through config secrets, and whenever you require some information like environment variables, you will do it through the config map. Okay, and we have some other topics also in between, like role bindings, cluster role binding, service accounts. We will discuss them on the way. Any doubts still here? Ravi, Gopi?
No, sure.
Okay, you understood well.
Yes.
Okay, shall I know how much you practiced? Like you created the cluster and practicing all these resources? Because from tomorrow we will go in deep.
Yeah, I completed Docker and I explored my own project in the Docker compose also. So it's got
Oh,
success.
okay, nice. Start with
Yeah, so
Kubernetes.
I'll start with Kubernetes, same project.
Yeah, okay. So you got Docker Compose with RoboShop running.
Yes, RoboShop running and my own project also it's running.
Oh, very nice.
So I think first day I told you I started working on this one. So I need your
Yeah,
help.
yeah, yeah.
Yeah,
Okay,
so now it's got success.
okay, very good. Nice.
Thank you so much.
Okay, then it's all for today. Then we'll see on Monday. We'll start with actual Kubernetes. Have a nice weekend. See you day after tomorrow. Bye.
Thank you.